Alright, this video is going to show an example solution to a problem involving simple circuits. And so keep in mind, when we're solving circuits problems, we need to start our solution with any of the four basic circuit laws that we've learned: loop rule, junction rule, Ohm's law for resistors, and then the conservation of energy rule. And so the circuit that we're going to analyze is a voltage source connected to two resistors, as seen here. And so step one in any problem solving is to draw a diagram. So you need to have a diagram. If it's a circuit, we need to add some additional information. We need to label for every device in the circuit the current in the direction of the positive conventional current that passes through that device. And you want to use easy to remember subscripts that match the label that you've given to the device. So for example, this arrow represents the current passing through this voltage source, delta V duke. I need to call that I duke. Alright, this is a junction. I'm going to label that junction A. And at junction A, the I duke is going to split into two different currents. I need to give those a name, and this needs to be I1 because that's R1. This is I2 to go with R2. This is junction B, where I2 meets up with I1 and then combines back to make I duke. Alright. The other thing that we need to indicate on our circuit diagram, so we've got our circuit devices, we've got our junctions, we need to identify the loops. And for simplicity, the only loops that matter in our analysis are loops that go through the voltage source. Alright, so there are two independent loops that include the voltage source in this one, and I need to make my loop go in the same direction as that positive current. So this is loop 1. A loop, again, has to start and end at the same place. So I'm going to start at the negative side of the battery, go around, and end where I started. The other loop for this circuit starts here and goes around the outside and comes back to there. So that's loop 2. Alright, there is a third loop, but I'm not going to write that loop rule because that loop does not include the voltage source, so we don't need it. Okay. So I've got a diagram. In this particular problem, the knowns are going to be delta V duke, 120 volts. R1 is going to be 720 ohms, and R2 is going to be 360 ohms. Alright, and generally the goal of a circuit problem is to find all of the currents in the different branches of the circuit, and also all of the powers of each device, and all of the voltage differences of each device. So we're going to find all of those things. Alright, so what we do first is write the loop rules. So for loop 1, the sum of the delta V's has to be 0. And I'm going to start at the beginning of the loop and go around and end where I started. So first I have a voltage rise across delta V duke. And then I go through a wire where the voltage doesn't change. Then I'm going to have delta V across this resistor 1 before I get back where I started. Notice that I'm adding the voltage changes. They add up to 0. Because R1 is a resistor, I get to use delta V1 is I1 times R1. That's Ohm's law. Be careful with your plus and minus signs in the loop rule. Ohm's law tells us the magnitude of the voltage drop across a resistor, but because it's a drop, delta V will be a negative quantity, since it's a drop. And therefore, when we do our math in the loop rule, we're going to have to put that minus sign in, because Ohm's law doesn't include the minus sign. So we're going to take this, put it in for delta V1. Delta V Duke, which gets a plus sign because that's a rise in voltage, minus I1 R1. It's minus because that's a drop, and because both the current and the resistance are positive numbers. So to make delta V negative, I've got to put a minus. Must equal to 0. So there's my loop rule for loop 1. Similarly, for loop 2, the sum of the delta V's is 0. Loop 2 passes through the voltage source, does not involve R1 at all. It goes through this wire, and then it passes through R2 and back where I started. So the correct loop rule for loop 2 would be delta V Duke plus delta V2 is 0. And like I did for resistor 1, I'm going to use Ohm's law for the magnitude of delta V2. It's I2 R2. So delta V Duke with a plus sign minus I2 R2 is going to be 0. That's a drop, that's a rise. Alright, so that's your next step. After you do your loop rules, the rest is mostly algebra. We want to find the unknowns. So in this problem, let's find I1. The loop rule is going to help us do that. So I1, if I just add I1 R1 to the other side, and then divide by R1, I1 is delta V Duke divided by R1. And again, if you're showing your work, show that that came from the loop rule. Let's put in some numbers. Delta V Duke is 120 volts. R1 is 720 ohms. That is 1/6 or 0.166 amps is I1. Similarly, I can find I2 from the loop rule for loop 2. I'm going to get I2 is delta V Duke over R2. That's 120 volts over 360 ohms. That's 0.333 amps. Alright, so from our loop rules we find the current. Let's see. Let's find a few other things. What is delta V of 1, of resistor 1? Well, from the loop rule, which was delta V Duke plus delta V1 is 0, we see that delta V1 is just negative of delta V Duke. And so that's going to be negative 120 volts. Similarly, delta V Duke plus delta V2 is 0, so delta V2 is negative delta V Duke. So it's negative 120 volts. Again, the negative sign means that the voltage drops when the positive current passes through each of those resistors. Alright, so we found the voltage change for both resistors, we found the current for both resistors. How about I of Duke? That was not known. Well, from the junction rule, if you look at junction A or junction B, alright, I in equals to I out. If I add all the currents going into a junction, it must equal the sum of all the currents going out. Well, the current in the junction A is I Duke, and the current out is I1 plus I2. Therefore, I Duke must equal 1/6 amp plus 1/3 amp, and that should add to 1/2 of an amp. Alright, so we found I duke. And then the last thing we want to find in a circuit problem is the power of each device. Power, capital P, is I delta V. So we want to do this separately for each device. So P1 has to be I1 delta V1. And so that's going to be 1/6 of an amp times negative 120 volts. And so that's going to be negative 20. Amps times volts is watts. So that's P1. P2 is I2 delta V2. So that's going to be 0.3 amps times negative 120 volts. That's negative 40 watts. P of duke is I of duke delta V of duke. Well, I of duke is half an amp. Delta V of duke is 120 volts. That makes 60 watts. And so notice, this should also make sense, that the power supplied to the circuit, which is 60 watts, supplied by the voltage source, is equal in magnitude to the power dissipated, which is negative 60 watts. Total power, electric power taken out of the circuit by the resistor. So that's worth knowing. P in magnitude equals P out in magnitude. Alright, so that's how we can apply our circuit's laws to this circuit. And you can use the same steps to solve any other circuit with loops.